And it's my great pleasure here to introduce my math brother, Richard Stanley.
Well, compared to most people at this meeting, the next speaker has shown a very impressive development since when I first knew him. This is Kenneth Stanley speaking on why greatness cannot
Hey, one of those weird moments, like, what are we gonna get into? The sun at the guest of honor, nothing to do with math, so what it is. It does tie in a little bit. So some of you will think this ties into stuff that we're doing. I was really surprised because you don't know what this is. Some of you might be curious what does Richard Sun do? I'll just tell you briefly what I've done is curiosity. First, I was a professor. Started a company called Geological Intelligence, sold that to Uber, where I was the head of basic AI research for a while. Then I moved to OpenAI and I led a team there. And then I started my own company. So that's stuff I've been doing, AI mostly. Oh, there it is. I'll list out for you. I did want to just make sure that I belong here. Straight to the source, the most reliable source. You can see that ChatGPT disagreed at first. I got worried. But I did suggest it could be interesting if we were related. It did agree with that. And so then I said, what if I told you we actually are related? And it said, that would be quite surprising. But then if you can see at the end there, it asked me if I have any sources of information to confirm it. Fortunately, I have nothing to provide. So we're going with speculation. Let me tell you just a second what I've been doing, the area that I was interested in. I thought I'm not familiar with this area. It's called Open-Endedness, but it refers to processes that continue to innovate and discover indefinitely without bound. In the time, it is relevant to, I think, math, because that's what you guys do, basically. Try to innovate without bound, continue to explore. These are called open-ended systems that do this type of highly creative systems. There are two canonical examples of what open-ended systems exist in the real world, and one of them is biological evolution. This is the tree of life here. You go over more than 1 billion years. You start from just one simple thing, a single cell, and you get the entire world of living nature produced in a single run, effectively, of an algorithm. This is quite different from a normal optimization algorithm where it's like, okay, here's the goal, and then we'll try to optimize towards it. You're done. It's not like that at all. It's like the longer it goes, the more interesting it gets. Or the other canonical example is civilization, which is kind of similar. Like you start with simple things like fire and wheels, and then wait thousands of years in this case, you have things like space stations and computers that keep going. And the longer it goes, the more interesting it gets, and the more that we invent. And so both of these are open-ended systems. They don't end. They actually get more interesting the longer you run them. And both of them are quite different from most AI systems, which is why it's relevant to AI. It's also relevant to AI because if you think about it, what explains the origin of human intelligence is biological evolution, which is an open-ended system. And then what explains the emergence of civilization is, again, intelligence. So it's like there's an open-ended sandwich with us in it. We're produced by it and we produce it. So it has a lot to do with what we are and what it means to be human. It's kind of important to understand how to create these things artificially, which is a huge and hard task. We actually don't know exactly how to do. So what I was just going to do for the talk is just tell you a little bit about my book. This book, which talks about some things in open-endedness, but and bigger issues too. That relate outside of, what I mean by bigger issues, outside of just computer science. So hopefully tie into some of the things that you guys think about at a higher level. Some of you may know indentation. I know it. Came out of China, apparently it was popular in China. And just wanted to acknowledge my co-author, Joel. Here's what I'm gonna tell you this story, it's a good story. We're researching AI, in particular open-endedness, and we ran into a flaw with the idea of setting objectives. I know it's a really general statement, but that's why it's so interesting. It's a flaw fundamentally with having an objective at all. And because of that, it's a strange twist. The consequences were well beyond the field of artificial intelligence. It's a very unusual story where there are implications that go outside of AI algorithms, algorithm insights. So to things like creativity, innovation, planning, collaboration, things that you do. So it's relevant, even probably to his audience. So the short story, but I'll make you believe this. You might not really want to believe this yet, is that objectives block creativity and innovation, and they can even block their own achievement. So there's a kind of paradox there. You can stop yourself by having an objective. And this is something I'm going to show you how we ran into this issue, why I wrote a book about it. And so the story starts with a strange place, actually, which is this website called Picbreeder. And it may seem like actually I'm off on a strange digression here, but it'll tie back, so don't worry. So you just got to understand this to be able to appreciate this really strange story. So what I'm showing you here is an old website from about 15 years ago that we put on the web for people to breed pictures. You wonder, why would you be doing some silly thing like that? It has to do with open-endedness. Like this is actually an open-ended system that you're going to see here, where people are actually searching a vast space of possibilities together and creating visions by liking into trees of life. It's what allowed us to go look in hindsight at what happened and then hopefully learn something about how such systems work. That's why we could do this, because we don't know how to build systems autonomously. We want to be able to build them, so it helps to build ones with humans in loops like this, because we're cheating and we're basically piggybacking on the fact that humans already know how to do it. So we created this for that purpose, but to users, it's like just a toy. So it's this toy where like you get these blobs. So you see, if you came in from scratch, you see like 15 random blobs, and then you could like pick one, and you could ask it to be a parent. And just intuitively, it's like breeding horses and breeding dogs. It's just breeding. So this is interesting to me. I'll say, okay, let's pick that, and then it's gonna have children. So this is the proud mom or dad or wants to be. It doesn't have to be. It doesn't have to be sexual. Single parent. And there is children, and just like if you have children, you can see the family resemblance, obviously, a lot of these, but they're not exactly the same as their parents. So that's just like normal thing you would see natural in breeding, and like so. It's true that this child is a little bit unusual. There's a mutation apparently, so we pick that one, and we can iterate, so we can just breed again. Now that's the parent now. There is children, and we can just keep on iteratively breeding over generations and play for a little while. And if you see this, you might think this might be fun for like 10 minutes. I'll have to do something fun. But actually, what happened is really, I think, really astonishing. This is what people did in this world. Now, I just want to point out that 99.99999% of this world looks like this, just garbage blobs, maybe interesting things. But the users found this. So this is like not retouched, raw discoveries. These are remarkable in a number of ways. In one way, I want to point out that these were discovered in just a matter of dozens of iterations. You know, so like you're used to modern machine learning, hearing about things that took like millions or billions of steps. This is just dozens of steps from a random blob to like all this stuff. And then look at how much they resemble the natural phenomenon. Like this looks like a butterfly, there's a car with two wheels there. This is obviously a skull. Jupiter, even look, it has the red spot like it should. You can remember though, even from random mutation, this is not a pre-trained system. So this is not like Dolly or modern generative AI. This comes way before any of that. This system knows nothing about anything in the real world at all. Every discovery here is purely through mutation. And yet this just keeps happening. So this is actually a really interesting phenomenon that's happening. If you're not convinced yet about how interesting it is, I'll continue. I'll show you a little more evidence about why it's so interesting. But I just want to throw it out there that I'm going to try to convince you that this is interesting. And one thing that I want to explain to you before I get into the really deeper issues is the mechanic that's under the hood, because just to be able to appreciate why this is interesting, there's one mechanic important to understand, which is called branching. What branching means is if somebody found an interesting picture, like if you were playing with this game and you found something you like, you could publish it back to the website. So for example, imagine you found this face, that's pretty nice. It's like a cartoon face, you publish it back, and then other people can see it on the site. And now other people who see that can branch, that's what the word branch means, you can branch from that and continue from your discovery. So it's like standing on the shoulders of your predecessor. So for someone starting from there, this is a more interesting game, right? Because they don't have to start. So they're starting from a face, so now they're starting in face space. So now it's just the same game, there's nothing's changed, it's just they're starting from something more interesting. And thanks to branching, I can just keep playing this game, that the mouth got more open there, so just play the game as usual. And if I find something interesting again, I can like publish it, there's a publish button, and I can publish that back to the site. And so the effect of the branching is that you're getting underneath the hood, you don't see this, but underneath the hood, this is happening in what biologists would call this phylogeny. So it looks like an evolutionary tree of life. And so in this depiction, like each connection here is actually an entire session. So you're not seeing every step, you're only seeing the beginning and the end of the session when someone published. This is just what people chose to publish at the ends of their sessions. But it gives you a sense of what you're saying, this collaboration, implicit collaboration. Because no one's talking to each other here, but there's about 30 people in this little tiny sub-phylogeny who implicitly collaborated, and that's where everything comes from, is this kind of branching. Let's just tell you some mechanics of branching going. So that branching behind these, like most of these had several people involved because of that sort of branching effects. But that's not the most interesting thing. So the interesting thing that I want to claim is interesting is that this shouldn't be happening. It's like, what are the chances of any of these things actually happening? If you think about it, the probability of these discoveries. Like if you look at the form of these pictures, like really look, like for example, if you look at the handle on this picture, what is the chance of that happening? Right? Like there's a stem on this apple, like this is a symmetric object, but there's this asymmetric stem superimposed on top of it. Like it's just no problem. And you have like look at the colors on the tropical bird or this Earth-like planet. What is the probability of all these things? These all seem like extremely improbable events, and yet they happen on a regular basis, routinely. It's constant discoveries of this type. What is the explanation for that? So actually, I know that actually this moment there's a divergence in opinion. We've spoken about this so much that I know that some people are right now really intrigued and impressed and say, yeah, I'd like to know what's the explanation. But I also know there's some people here who are not impressed at all and have a question because they're saying, wait a second, I just want to address those people for a second. The people who are not impressed. I know what you're saying. You're thinking, wait a second, this is breeding, right? Like, so like, for example, if I wanted a tropical bird and I just came in and just had random blobs, okay, granted, none of them look like a tropical bird, but one of them looks more like a tropical bird than the other, so I'll just choose that one. And then it has children, and they still don't look like a tropical bird, but one of them looks more like tropical birds, and I'll just choose that one. And so if I keep playing that game like that, wouldn't I get a tropical bird? I mean, that's what breeding is, right? Like, why should I be impressed here? Well, here's what's interesting about that. If you believe that, your intuition is totally wrong. It's intuitive to believe that, but that isn't the way that the world works. In fact, the fact that it doesn't work that way is why most people are so frustrated when you play this game. Most people who come into the site think it works that way. So like, in other words, they set an objective, and then you start trying to breed towards the objective, and then they get stuck. It's very frustrating. And they think, well, how did people do all this? It doesn't work. The system is horrible. Then they just give up. And so it doesn't work that way. And just briefly intuitively, like why it doesn't work that way is because if you think about it, this is a complex space. This is a huge high-dimensional space of all possible history, all of the geometric relationships that could exist. And the connectivity of that space is such that the things that lead to things don't look like those things. In other words, it's a deceptive space. It's confusing. You don't know what the things that lead to tropical birds don't look like tropical birds. So if your heuristic is, oh, I can just make it more and more like a tropical bird, you'll just hit a local optimum. You're stuck. You can't do it that way. And so the intuition is incorrect. You can't play that way. You can see how this is beginning to tie into the theme of objectives, right? Because that's objective setting. Set an objective, move towards it methodically, like follow the gradient. Doesn't work. Starting to see a connection. Why does it get a tie-in? But the real interesting thing is, given that that does not work, it raises a really deep question, which is, how is this working then? What exactly is going on? Why would this routinely happen if just setting objectives and going towards them doesn't work? how could you make these kinds of discoveries on a routine basis? And so I actually wanted to tell you the answer to this through a story. And this is a story that I like because I was the one who discovered this particular object, which is, I think is like a car. It's got two wheels, it's got a hood and so forth. And I discovered this car, so I know the whole story. This is actually where all these ideas came from. I discovered this car. Very shocked when I discovered it, because I wasn't trying to actually. And so what actually did happen is that I wasn't looking for a car. It's a very important part of the story, but rather I saw this on the site. And this was in the archive that had been published, so someone else had discovered that. And so I chose to branch from it because I thought it was interesting. But the reason I thought it was interesting had nothing to do with cars, is because it looked like an alien face. I thought it was an alien face. In fact, I think it looks like E.T., like the 80s movie E.T. That's what I thought. I know someone else once told me it looked like a problem, but that wasn't me. I thought it was E.T. So I thought if I branch from that, I'm going to get other aliens. And I was actually excited to get some aliens. But then something happened, which was totally unexpected, which is that these eyes, they just started descending, going down. That's just random, but I understood, like, at some point, as they were descending, it just suddenly clicked that I was getting a car. I never would have imagined you could get a car from this. In fact, I don't think I ever would have imagined you could ever get a car in this entire system because of the complexity of what a car is. But once I started seeing the eyes going down, it just suddenly clicked that they could be wheels. And then I could steer it towards a car. So that's how I got the car. Probably not trying to get the car. Or rather, just to be more specific about it, this is a really weird story, and it's a very strange sequence of events. So I just want to highlight how strange it is by just going over the two things that have to be true for this to work. The first thing is that I had to not be trying to do, or someone had to do something that I was not trying to do, which is make it see on my face. Like I had nothing to do with this, so someone had to do something that I would not have done. That had to happen. But then I had to not be trying to do what I ultimately did. Because after all, if I was looking for a car, I would not start with an face. Because it's only because I don't care about cars. And so if you put that together, you get a really strange story. You just say it all at once. First, someone had to do something that I never would have done, and then I had to not be trying to do what I ultimately did. And only then do I get this. So now that sounds like a really big coincidence. It's like I just won the Picbreeder lottery. What are the chances of those things coming together? But here's the really astonishing fact, is that actually this is always the story of discovery. It may sound like it's a very strange, exceptional story, but rather this is the rule. It's not the exception. That's how discovery happens. See, you might say, well, how did you know that? How do you know how people discover things? Well, we know because that's the advantage of creating an artificial open-ended system, is we have the entire history of every decision anybody ever made. Like, unlike biology, they dig up fossils out of the ground. The fossils are all here, and we know everything. So I can just go back and see that, like, okay, there was an egg with a hat. That's what I call it, an egg with a hat. And then somehow someone branched from that and eventually got a pitcher. And you can see in hindsight that the lid of the pitcher is somehow mathematically related to this hat. But going forward, no, it's inconceivable that that was the reason. Like, it's not like this person was thinking, oh, finally we can get pits. Or this dish leads to a skull. So, oh yeah, of course, this is what we need to get the skull. That wasn't what they were thinking. This looks like letter G leads to Jupiter, and so forth and so on. In every case, it's inconceivable that the essential stepping stone was discovered with the final discovery in mind. Which means that the experience I had was not an exceptional experience, but the rule. And it leads to this really strange point. So the stepping stones almost never resemble the final. Which means the moral is you can only find things by not looking. I gotta absorb that for a second because it's actually hard to digest that. You can only find things by not looking for them. Now this is where it gets a little bit interesting because it's really, to me, it was like a mind-blowing discovery. When I saw that, I thought this was like the craziest thing I've ever seen. Because like I've been taught, I was in computer science. Like I was taught like you set objectives and you go towards them. There's a lot of names for that kind of work. You call it top-down design or bottom-up design or optimization, gradient descent. There's just like tons of names for setting an objective and figuring out how you get there. That's how you get things done. But in this system, everything works completely the opposite way. That's the single best way to fail is to do any of that. And I was trying to wrap my head around that and think, well, what does this mean exactly? Like, what are the actually broader implications of this? And one point that starts to come up here is the question, are there any broader implications? Like, is this just a story of Picbreeder, or is this the story of like the actual world we live in? Because if it was just Picbreeder, then, you know, you can put away your anxiety to go back to it, like, you can go pursue your objectives. But if this is actually not just about this little Picbreeder toy, if this is about the way the world works, then it has huge broad implications. Because everything we do is basically run by objectives. And by we, I mean not just personally, but institutionally, everything is run by objectives in our culture. So I will argue that that is the case. That's why this is important. Is that this is not a special situation. Picbreeder is not some weird anomaly. This is actually the way that the world works. To give a little more insight, like why the world works this way, it's actually really simple. We already know about this. But what we don't know is just how pervasive this phenomenon is. So it's what one word for this is deception. Deception means that when it looks like you're on the right path, but you're actually on the wrong path, or it could be that it looks like you're on the wrong path, but it turns out it's actually the right path. Those are deceptive situations. And you can see that deception lurks in the trajectories of this system, in the sense like that, like this donut here looks like it's not leading to a skull. Like if I wanted skulls, I would not choose donuts. This is deceptive. But in fact, it is an essential stepping stone on the road to the skull. And you can see it's only when you start to get really close, like here, maybe you start to see some of the sense there's a face-like aspect coming out here, that you might be able to think objectively. But when you're distant, when you're far away, there's no way you can ever figure this out. It's deceptive. And so the issue here is that this property of deception is actually the ubiquitous property of complex spaces. Or we could say hard problems, complex spaces, or hard problems, basically the same thing. Like, in other words, it's just like a truism that like the reason that a problem is hard is because we don't know what the stepping stones are to get to the solution. Right? Like if it's like by definition, like if you knew what the stepping stones are, then of course you would just follow them. It would be a solved problem and it wouldn't be hard. You don't know what the stepping stones are. This is always the situation in like super high pressure complex problems. So it's important to emphasize that you're talking about like complex problems. So like a lot of objectives do work because it's not a hard problem. It's like if you want to become an accountant, you know you could major in accounting and then like you become an accountant. It's not that it's easy. There's a lot of effort involved, but there's a known stepping stone. You know how to do it. I'm talking about problems doing it. So it's something like, you know, curing a disease or creating AGI or like finding unlimited clean free energy, something like that. Like, who knows? No idea. It could be somebody researching trees that figures out how to cure a disease or something like that. It's deceptive because if we only put all our effort into funding that disease, researching that disease, the guy doing the tree sap wouldn't get any funding, and it's deceptive, so we wouldn't get the solution that we hope to get. And so this property is actually how the world is constructed. And so this is a very important thing to recognize when you consider how pervasive objectives are in general. Now, what I wanted to point out here is I want to just give a little evidence that this is a legitimate insight, just to give it credibility. So, like, in some sense, I don't want to get like an AI talk really like it's been about like results and impress users, like look at all these great results. It's more that I think it's really interesting to see that there have been many AI algorithms and experiments that have originated with this insight that reinforced and reestablished this underlying insight to be true. So for example, like we created, like when we got this idea, we said, maybe we can make algorithms that like take this seriously, you know, like, that aren't objectively driven, because like almost every algorithm in the field of machine learning is objectively driven. So like novelty search is one of the first ones, and it would search for novelty, with no specific objective, and it would do things like it would find like it would find walking gaits for this fly guide, for example. They're better when it doesn't actually try to solve for walking, rather just tries to do novel things. So just trying to do novel things would lead to a better walker than optimizing explicitly for walking. So the one that was optimized for walking would be worse. It's again very counterintuitive, surprising to people to see the result. But whenever there's something really counterintuitive like this, it's just the same principle of deception. The stepping stones that lead to walking may not look like walking. So if you don't care about walking, you actually have an advantage because you could try things without worrying about that. Like how to walk, and you could try the deceptive stepping stones. And so this led to like entire fields, like quality and diversity algorithms, the whole field. Hundreds of papers published, see it. Journal of Nature and so forth. And so these are like repertoire oriented. They're like sort of like in the spirit of evolution. These are algorithms that try not to solve one problem, but to solve like thousands of problems all at once. Like the way evolution works. It's photosynthesis, like flight, and human intelligence all in one run. They're trying to do things like that. So there are like whole fields based on this. Again, not to impress you or something. Yeah, I talk. We have the paper at the conference is just really to say there's credibility to this point. Like if you're doubting it, I'm showing you that. Look, there's been tons of research now that's confirming that this objective paradox is a real thing. So what's really interesting though to point out to this audience is just the profound implications that go beyond data on the machine, which is really unusual. I don't know if I've ever heard of AI results where you can actually do social critique based on. But just look at these points and just think, what does this mean? Like the path to success is not returning to success. Or to achieve our highest goals, we must be willing to abandon. See, what does that actually mean for you or your institution? It is in your interest that others do not follow the path that you think is right. Why would that be? Because they will lay the stepping stones for your greatest discoveries, like the alien face that led to my car. So you don't always want to persuade everybody that you're right, because then everybody will converge. You won't get the divergence and the diversity that's necessary to get your system going. So these are not just computer science implications. I started like, so I decided to write a book about this eventually. The book was, as I started at the beginning, the book that was aimed at audiences well outside of my field, aimed at general audiences, because I started to realize that this actually matters to people beyond my field. Like it took a long time to realize that because I would just go talk at AI conferences. People were inviting a lot because it's very contrarian, so people like that stuff. If they disagree, they like hearing contrarian stuff. But I started noticing people would ask me, what does it mean for me? Should I think differently about it? Or my company and research group, like, what does it mean outside of just like writing an algorithm? And it really finally sank in when I went here to the Rhode Island School of Design. Like somebody saw me at at one of these talks, who was a student here, and said, you should talk to this audience of artists at my school. I think they'll really like what you have to say here. And so I went to this, it was very strange for me, I don't usually talk to this kind of audience. And I could see maybe they'll find this interesting, so it was a fun experiment. But what I didn't expect was that when they were having private meetings with me after, the students could sign up, some of them were on the verge of tears from this insight, which is just a purely algorithmic point. I don't know if the algorithm has ever made me cry before. But the reason for it is what they were saying is I've never been able to justify what I'm doing here. It's like, why are you making this pointless stuff? How are you going to make money? Parents want it, your teachers want it. Why did you create this artifact that has no purpose? But this is saying somebody has to follow the path of the interest. It's necessary so that we can get the stepping stones that will lead to important discoveries. And so it's actually correct that somebody should be doing that. And it finally justifies what these people are doing with their lives. And then it just, I felt like, wow, this is actually a really important social topic. I just hadn't thought about it before. But it's like, people actually really care about this deeply. And everything is so objectively driven in our culture that I just felt like we have to let it go. And that's why we wrote this book. It was a very career move to write a book like that. But I felt like this kind of discussion is very important. For this audience, it's very interesting because I feel like you got to do this. Like mathematicians, you're not necessarily trying to solve a specific objective problem of the society or something like that. And I wouldn't put words into your mouth, but you can tell me how you do your work. But I imagine some exploration is specific exploration. And it's interesting how important this is. Somebody's doing something. And so I sometimes call these like treasure hunters. It's like the term used for this kind of processes, non-objective processes of exploration. Like the Picbreeder is like that, the novel research algorithms like they don't have a specific objective. Instead, you could think of it as like there's just all these treasures like buried in the dirt in the forest. And if you find one, there's others around. But you don't know what they are. You have no idea. You just have to dig them out. So you can't have an objective. but you can just look around and see what's interesting. And so, of course, the bigger treasure hunters are like natural evolution, civilization, like there's no final goal for evolution. But humans are not the final goal. That's why we exist. Like if we were the final goal, then they would have been giving IQ tests to single cell organisms. They'd all be dead. And we wouldn't be here either. Like it's because we're not the goal. That's why we're here. Civilization also works this way, like there's no final objective. It's true, some people at some places had objectives, but in aggregate, there's no unified aggregate objective.
Yeah, but it's suboptimal. Evolution is suboptimal. And with a little bit of objective, we can make it even more optimal.
Well, there's a whole field of evolutionary computation. And actually, evolutionary computation was used as an optimization algorithm for decades. That's basically how it was used. It's a misapplication of evolution. Evolutionary computation gets stuck in local optimum. It's quite less impressive than natural evolution. Nothing like the tree of life developing in a computer. Because people misunderstood that like, actually the power of evolution is the fact that it's not objective. And so like the question is, where does the power come from? Like usually we think of optimization as the source of the power of the search process. Like you follow some gradient towards something better, like that's really the power. But that's not how these treasure hunters work. They get their power from something else, which is the word collecting. It's the collecting that's power. What are they collecting? They're collecting stepping stones. In other words, the more stepping stones you have that are interesting, the more interesting places you can go. That's why Picbreeder on day 1 is not very interesting, because there's just lots. But Picbreeder on day 300 is very interesting, because there's all these jumping off points that didn't exist before. It's the collecting that is so powerful. That's why like, all these processes like evolution and civilization get more interesting the longer they go. The next generation of inventions can be more interesting than the previous generation. So these stepping stones don't have to be solutions to particular problems. And the thing that makes it interesting is the process is divergent. That's why it's so creative. So it's the divergence that's giving the power to the process. And I'm like, wait, it's long, so I'm just gonna point out that the whole world works this way. The whole world works this way. So science funding, corporations, educational institutions, the government, philanthropy, even your personal life, you probably set objectives. Like you should be questioning, we should be questioning this. This is the myth of the objective. The fact that everything requires an objective to be able to do it means that we have a problem. The alternative is to follow things that are interesting. Interestingness is subjective. Everybody's afraid of talking about subjective things, but at some point you have to talk about subjective interestingness in order to follow a non-objective path. There's something to remember, it would be this section, that's the explanation for this paradox. I started a company based on this, which is actually a social network. I tried to make it work the way that I did, like a non-objective network. I mean, that's what I've been doing. That's what this job is. You can see that this idea has been around for a long time. Good travel has no fixed plans, is not. But what's new here is the evidence. People say things like this all the time, but it sounds like it's just philosophical. But I'm not making it philosophical. I'm making it empirical. So I have empirical evidence to the last few years. And grandchildren.